Καλό μήνα.
Good morning, everybody. Today is the first day of December. We are saying good month in Stylinica. We are saying Kalomina. Kalomina.
Μήνα. Good month.
Dr. Rajai with us.
صباح الخير كيفك
صباح
دكتور؟
الفل.
Good morning everybody.
How's everything in Greece?
It's good. Not really good, but we are good. We're still okay.
That's nice. Yeah, that's nice.
And what about you?
Yesterday we have around 5,300 cases only.
Oh my goodness. Okay, you're out of limits.
But we are not in lockdown. Yes.
Without lockdown, everything is open?
Yes, everything is open.
No, I don't believe you. Really?
Yes. But no schools, no universities.
Only market.
Only market, yes.
Business. But it was closed and now it's opened again?
Yes.
Okay. No, we are still closed here and we wait to see what will happen.
As I heard yesterday, the Prime Minister, he is saying he is going for 14th of December with the lockdown.
I understand. For the economy.
Yeah.
He has to check this. Okay.
Yeah. Dr. Rajay, do you think we have to start?
Yes, Doctor.
Okay, please.
Okay, thank you.
Okay, thank you.
Hello to all of you again. This will be the last session of our project because today we are going to see the dimensioning, meaning the checks and how the software inserts the reinforcement inside the elements, the structural elements. So now I'm going to share my screen with you. And let's check these things together. So, the last week we talked about the analysis. We did a static analysis, meaning only with the vertical loads without seismic loads. And we also saw the results in post-processor. So now we go to the next step, and this is the last step, is the members design. And let me explain you how it works here so you can see the scenarios. So we also have another scenario like we had, you remember, we had in analysis. So scenarios means that we need to select a norm, okay, in order to do the design checks. So we work with Eurocode 2 for concrete, 3 would be for steel structures. So we keep this, we have it from for default because you remember in the first window we selected Eurocode, the general Eurocode. And now the important thing is to talk about the parameters. Before this, we see this is a command group called beams, another one called capacity design, columns, footings, slabs. So we arrive until here because then we have the steel and timber structures checks that we don't need for now. And then there is the masonry design. So for us, all the commands that we will use are here. And what this means that for the first step, we will check the beams. Then arrives the capacity design. This is something that we will not talk about because it's something according the seismic loads and the seismic part. So we don't talk, we will not talk about the capacity design. But we will see then the checks of the columns and the footings and the slabs. In order to receive the reinforcement of the slabs, we absolutely need to have the strips. So I go to the slabs and I check if I have the strips. You remember I have one direction slabs, so I insert this strip in the Z direction. So I am ready. I go back to members design and now I open parameters. Here you can see a window. There are a lot of tabs inside, but the most important thing is to select the combinations. You remember that I could have a lot of analysis, but the combinations tells me what results I will keep for my design. So in this case, I will select the static combinations. You see here there is an error in the combination file. It's not an error. The software needs the seismic loads. So in case there are no seismic actions, you will see this message. In your case, you don't care about this, so you just say okay, and you have the only one combination that you have for your exercise. Then if I open slabs, beams, I will find some checkbox that gives me the opportunity to consider some checks or not. So I told you about the capacity design. This is like an amplification of the loads, okay, that are important in some cases to do. But in this case, I don't need them. That's why I will not have the checks here. And for example, there is the torsion checks or the serviceability. In this case, I have only one combination, so it's not important to see these tabs, okay? But I want you to know what is inside these tabs, okay? And so for me, the most important thing is to select the combination. And the last one is the steel reinforcement. Now, if I click the steel reinforcement, I see the tabs for the structural elements. And inside this, I can decide the minimum and the maximum of the reinforcement that I want to use for my checks. So here, for example, if you go in columns, you will see that I will not insert inside my columns diameters of bars that are less than 14. If you want to do another kind of reinforcement for your elements, you need to come here and say, for example, I need the minimum to be 12, okay? Otherwise, you keep the minimum that Eurocode 2 impone, okay, needs. The same thing for beams, the same thing for footing connection beams, etc. Okay, so this is what is here, is the selection of the bars that the program will calculate and insert inside the elements. So let's go back. For us, the important thing is to calculate the combinations, and then there is a magic command that calls automatic design. So if I click automatic design, the software will do all the steps, okay, by default, by itself, without the need to do these things manually. So I can click automatic design, or I can come here and do all the steps manually. What are the steps that the commands do with the automatic design? The first thing is to find the continuity of the beams. What is the continuity? Okay, this is a beam, but here there is a continuous beam. So the reinforcement should consider this continuity. That's why I need to say overall continuity of beams for this level or for all the construction, but I have only one level, so it's okay to click here. You see, you will receive this square design in red that tells you these are the continuity. After this, it's possible to do the check reinforcement. Otherwise, if I click check reinforcement without the continuity, the software will give me a warning. So, continuity the first thing, reinforcement check the second. Single or overall, I will select overall for the level and I click OK. And now you see the software that do all the calculations according Eurocode 2 in order to insert the reinforcement inside the beams and gives me the information in color. So when I see green or blue for the columns, I am happy because this means that all the checks are passed, are okay, and the software could find an appropriate reinforcement to insert inside the beams. But let me show you what the software did. I go on the results and I can see results, exploration. Okay, let me click results and I click inside the member of the beam, and now you see the results in order of calculations. So as you see here, it calculates the reinforcement. This is the required reinforcement, and this is the final reinforcement. So these are all the things written, okay, and you see the bars that it used, and also here you can see the calculations. But if I go, it's in the reinforcement detailing, and I click on this mathematical element, I will see the reinforcement inside this continuity of beams. Okay, so here I can have also the opportunity to see in this way, so how it is the reinforcement inside, and I can see it also in the 2D view, and you see the reinforcement inside. So here it's something that I can manage. So for example, I click here in this span, and if I click to see inside the span, I see the software inserts 2 bars with diameter 14 for the top and 14 for the bottom part. The that calculates, okay, you see the anchorage here, is according Eurocode 2. So according to the bar, according to if the reinforcement is up or bottom, calculates the length of the anchorage. And here you can see the required reinforcement in meter square, in centimeter square, and the placed one. And if I select, for example, two of diameter 12, you will see here that becomes red because the place is less than the required. So you see here that found the software the diameter that needs to insert in order to have this placed centimeter squares more than the required. And this is for the main reinforcement, and you can see also for the support reinforcement. So if I click here, okay, I see that I have two more bars of 16 diameter that were necessary for this support part. And the same thing in the other side. So if I click here, it becomes red, and now I see this part. And this is how it works. I can see also the stirrups, and the stirrups are in the bottom. So here you can see also the details of the reinforcement. You see the bars in the bottom, on the top, and you see the stirrups around. And also here you can see the diagrams. So if I come here on the diagrams, I can select to see the bending moments, the shear forces. I can see, for example, the placed reinforcement and the ultimate moments, for example. So I have the opportunity to check all the diagrams of the envelope. In this case, you have only one combination, so the envelope is the same of the combination one. Otherwise, I could select another combination, or you can see it by load cases. So you have the dead and the live loads, so you can select to see for the live loads only. And here you can see that there is for each, it's like cut the beam in 50 centimeters, okay, and see for each 50 centimeters, each cut, what is the shear, the moment for the only for the live loads, for the dead loads, or for the combination of them. So this is how it works. And also I would like to show you that you can see here that you have the possibility to click multi-span reinforcement. So in this case, the software considers the one only bar to cover all the needs of the continuity of beam. Otherwise, you see that I have pieces of bars. In this case, I have one only bar for all the continuity. So this is also what you will receive in the designs. Here you can see also that there is a table. Let me do it a little bit bigger. There is a table that contains all the information of the reinforcement of the beams. And the most important thing is that if I change something, this changes accordingly. So if I select, for example, to have another dimension, you see here, it's automatically considered here. So these are the information that you can take inside this editor, this reinforcement editor. I click OK in order to keep the changes, or I can just click cancel in order to leave what I had previously. And you can do it by click here and reinforcement detailing, or you can just come here near with the mouse, right click, and here you can see the detailing. So now this is a continuous beam. So you see here the reinforcement inside this beam. Okay, let's go on. That was the beams reinforcement. Let's go on with the columns checks. So I click here, overall, and here I see I can do the check for level, for all the structure. I can check columns and walls. Walls means that there are vertical elements like columns where the ratio between one direction and the other is more than 4. So in this case, I don't have walls because there are only 30 per 30 columns, and I click OK, and you see here that I have a lot of problems on my columns. Let me show you this thing. Why do I have these problems? I need to go to check inside this column. So let me open the results, open this one, and check. I have a problem because I need to run again. No, I have 0. That's why I have this problem. So let me go back to the analysis, because by talking about the things, maybe I need to run again the static analysis. I don't remember. I didn't run the analysis previously, so I need to run the analysis. Exit. I check the combinations again. So I remember that I had this one. Let me check this one. This is my OK, and say not serviceability. Let's put it ultimate. OK. Let me save it as static. Yes. And just go back here and I will do the checks again. So let me overall, OK. And now I will check also the columns after it finished. You need to wait until it finished in order not to have problems to no, I still have these problems. I need to check it out. Let me see why. Okay, I see that I have a nice reinforcement here, but I want to check also the checks. So results. It's something here that I don't like, because I see that it doesn't calculate, it only calculates the minimum of the reinforcement that the norm decides. So let me go back to make some checks. That's why I see all these problems. Let me check the loads. I think everything is okay. Let me check the model. Okay, this is only a warning because I don't have the connection beams. I don't care. And let me check again here in static. I want to check that I have, yes, I have the dead and the live loads that will be considered one time each, and it's okay, and exit, and I will run again, execute, exit. I already have the combinations, okay, and I will also read the checks here because I want to see. Okay, I have, okay, no, I don't have any kind of deformation. This is something that I don't like. So let me do the check again. I will do a general static analysis, and I will consider only, so let me do this. I will run the, that's why I did this. So I initialize data and I run again the Eurocode analysis and not only one static. So I will run the Eurocode analysis, but I will consider only the combination that you want. So I will uncheck all the seismic combinations, and I will do calculation and I will receive only this one. If I could remember, it was 1.2, correct me if I am not right, and 1.6. I think that was the combination that we will use, and I will write save, and I will replace this one, and let me say okay. So now I have the same thing that I did with the static, but it is according the Eurocode. So let me check if that was the problem from the software, because it needs to have the Eurocode. Let me check here that I have no. Okay, let me just take a look, and I hope that it would be good. Otherwise, you will have a little patience in order to check what happened. So that was the combination. Okay, and let me do the automatic design in order to make, not to make the same steps every time. Let me check now. Okay, okay, now I am good. So, okay, I explained you that the thing is that I was according Eurocode, so the software needs a regulation in order to go on, okay? That's why I didn't use the combination, the analysis of Eurocode. I had only one static analysis and it couldn't go on. So I explained you again, to do this thing or to create a static scenarios with only dead and live loads, when my combinations consider only the dead and live loads, is exactly the same thing. The only thing is that here I am according a norm, okay? So please consider to do these scenarios and not only a simple static one. So when I come here in members design, I go according to Eurocode again. And now, as you can see, I can go inside this. I can do here results, okay? And I can select to see the detailing. So I can click this and opens the detailing. Otherwise, I can just come here, right click and see again the detailing. So let me check here. You see that in the main reinforcement, you see that I have 3 bars of 18 in this part and 2 other in this part, and here are the stirrups, and you see the distance between the stirrups, and you can also take a look inside the column. Oh, I'm sorry for this. So let me open it again. Just a second. It's cold outside, that's why maybe also the software has some cold problems. So let me go here. Okay, we were here in members design, so here we are, and let's open again the detailing. And here I talked to you about this. I will try to do this again. Yes, here we are. So I can see also the stirrups, how they are inside the column. So I close this. You can see also the diagrams. Okay. Always you can select to see by combination or by load case. So the first and the second load case or the combination, okay? And also here you can see, you can receive the internal forces. The same thing that I told you for the beams. You can cut the column in pieces. Each one has 50 centimeters. You can also change it if you like. Okay, you can change it here. You can type, for example, 1 meter. Okay, so in this case, when you select the combination, you can see it for each 1 meter. So you can check the value of the moment and share, etc. And here you have also the possibility to check the results. You see here I have all the results that I need, so I can see the shear forces, the axial forces, I can see the moment here, and you can have in bottom, in top, and of course in the 2 directions. And here you can see also the reinforcement inside the element. So even here you can do the changes that you like. I have the possibility to, for example, to say that I don't want to have in the corner this 18 centimeter. I can change it. I can add or I can edit bars. Let me show you this. I can do it by right click. I can decide to have another bar. So if I click here, I have a 16 now. I can edit bars. So select here and change for all of them. Okay, so I can change all of them in the corner, or I can add bars and I can add it, for example, I can say here the distance that I want to have between the bars, or I can just, I can just click add a bar, for example. I can add it. Yes, I have 0 here. So I can add bar between, let me select. I can add it between, add between here. Why did it tell me this? Stirrups, a main reinforcement. I click 1. Edit, no, I click 1. Add. I already, yes, okay. I put a lot of them here. I already have one here. So that's why I cannot, yes, I have another down of this. So that's why I cannot add, or I can insert side, okay? I cannot put here because I am in the corner, but I can add a side one. So now opens this, okay? And I can add one between this and this. So I have a sidebar, okay? So I couldn't insert because in the corner I already had one, but in the side I can decide to put other bars. So add also another one between this one. And after this, I can also insert stirrups. So I can decide the type of stirrup that I want to insert, and I can say, I can select this, or I can say add stirrup, and I can just click here, 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 and add another stirrup, okay? Or I can delete one and keep only this. So why I show you this? Because the software gives you the opportunity not only to receive the reinforcement that the regulation needs, but gives the opportunity to change it. And this is very important when you work with existing buildings, because in the existing buildings, they already have the reinforcement inside, and this is how you can manage to insert the same reinforcement that you need to have in order to check an existing building. So cancel, and the next one is to do the slab calculation. You see that I have the check. This is because I selected to do this automatic design in order to not lose time. So the software already made this check. So okay, so I have the check, and I can go inside the results and click editor. And if I click editor and I click on this strip, I will see in each span, I go in the next one, and the next one, and the next one, and the next one, until I arrive to the last one, and I see the reinforcement inside. If I click here, I can change even the number or the diameter, and I can see the same thing here, the required and the placed. So if I come here and I change, for example, I select 12, you will see here that change also the place, and I have the required, but it changed the place. So cancel, and now when the checks are finished, okay, let me tell you this. In case that, for example, this beam had a problem, in this case, for example, if it was very small and it couldn't pass the moment checks or the shear checks, okay, I should work on this one. So the good thing is that you can just select the element that contains the problem, change here the some dimensions. For example, I need to make it more big, so I need to say, for example, that it could be 50, or I can change the height of the beam. So in that cases, I can make the changes. I click OK. I can do for only this element single check. Okay. If I see that now it's okay, so I see that past the problems, I know that I can keep this element, changing of element. So now what I need to do is to go back on the analysis, I need to run again the analysis, so I will initialize data in order to consider this change. Initialize data, automatic procedure, and then I go again to do the member design for all the elements, because if I change one part, I can do the check locally, but this influences the entire structure, so I need to do the checks again for all the structure. And now the last thing is, when I did this, I have to go on the bottom and check also the footing reinforcement. So overall, I see that I have the footing reinforcement checks, and here in the results, I can also see the editor. This is another kind of editor, so I see here the footing, and I see the reinforcement in the Z direction and in the Y direction, I'm sorry, and the Z direction. And also I can see the results, so I can click here and opens the results, so I can see the calculations inside the footing. So finish all the checks for all the elements of my structures. Everything is blue and green. And now I can save my project and go on the drawings. I open the drawings, and here I have import, import again, and the software automatically opens the name of my project, the current project, and tells me to find the level, to define the level that I want to open. So I just click one here, I have only one level, find. It gives me the file that contains the designs. I click here and OK. OK, and now here I have all the detailing and all the design that I need. So if I come here near, I can see the name of the beam with a number. I can see all the bars and the reinforcement, even the support reinforcement or the reinforcement of the entire beam. I can see here also the reinforcement of the slabs, and here I can see the details of each column with a number. And here on the bottom I have also the two tables for the beam stirrups table and the main reinforcement table of the beams. This is a design that can be that is editable. Okay, so here you have all the commands that gives you the opportunity to move a little bit the text here in order not to have one text over the other, etc. So you can do it here, working, for example, with edit. You can mirror, copy, move. Okay, you can delete various things. You can trim, expand. So you have all the design commands here, or you can add, for example, dimensions, label styles. Otherwise, if you don't want to do these things here, but you want to work with the CAD software, because you have also your table and you need to manage it as you like, you can just export as a DW or DXF file. So you just export, you give a name, 1, 2, 3, 4, okay, as a DXF or a DWG file, save, and now if I come here, I will find this 1, 2, 3, 4. Where is it? It was one. Okay, here it is. So if I click here, I open it with G-Star CAD. Is a CAD software. And here I can see my drawing details and design. And here it is. So now I can manage everything here. Okay, I can move it. I can work as I know how to work inside the CAD file. The last thing, so I close this, and the last one is to have, I don't care to save it, and the last thing is to have the printouts. So here on the add-ons, the last command, of course before the optimization, is the printouts. So here you can find all the available chapters, and you need to select from this, because here, as you see, there are chapters for timber, steel, masonry, so you don't care. But you can just decide to have a cover, a short description, and then you need to open inside, for example, here, the analysis that you run. So here we work with Eurocode 8 general static, and you see that there are all the data that comes from all the calculations that the software made. So you can see, for example, the support reactions, you can have the load combination, you can have the checks, and also in the design you will have the slab checks, and then the column checks, and then the beam checks. So let me keep this, and I will show you. I click project report, and now the software produce all the report of my project. Okay, here I can have it. I will show you. Okay, and here you see there is the support reactions, and I go down, and here is the load combination that I used, and then you see the checks for the analysis that I made, and then I start with the slab design, all the calculations for the slab, for the columns, and at the end you see for the beams with also the diagrams that we already saw. And so you can print what you need. You can also save it. You can save it as a doc file or as a doc file. So you can also manage it, so you can type here. Otherwise, you could, let me close this. Here there is the building data. So if you type inside this data, you will see in the cover, in the description, you will have all this data inside your printouts. So, and you can also make, for example, a print screen. Okay, so you can print screen and keep your project. So you can select, say that this is an image that I want to save. I can save it and say, okay, let me go in the desktop, save, and now I can come here and I see, for example, here, building data. Okay, I type something like this, I don't care, so and now you can also decide to insert a picture. So the desktop, did I save it? Okay, let me, BMB, I didn't save it as a BMB, so file, save as a BMB, okay, save, and let's go back here, and here it is, and open, and okay, and now if I select, I will see this, what are they? No, what I miss. I also need the picture, okay, report. Oh, short description, project. Here it is. So here in the short description, I can see all this data that I insert inside. So here the project is finished. Okay, as you see, we have everything done, so I can print my designs, I can print my checkouts, and I can start create my my project. The last step that somebody could do is to do the optimization. Okay, this is something that is not necessary for the in order to create this building, but it's necessary in order to save money, because as you see here, I create this building by considering a beam that has these dimensions, but maybe I would not need so much concrete, because maybe the software for this building, for these loads, it would be necessary to have, for example, a beam with 50 here or 40 here, okay? But I couldn't know this because I passed the checks, everything is okay, and I couldn't know if I could reduce these dimensions. Thank you. So this is what the optimization do, okay? Gives me the opportunity to define the function according what I want to make the reducing, okay? And see at the end what would be the better project to have, okay? But this is another part for your project is not considering. So I believe that we need to stop here, and your professors, you will decide if you want to make another lesson, maybe when they finished, when the students finish to do this project, in order to see what happened after the optimization.
Could we do the optimization and leave the program running and discuss about the student ability, if they understand or not? I think it will take around 10 minutes to make optimization.
Okay, we can do this, of course. Yeah. But okay, first of all, I need to design. Okay, just 2 words to say that the objective costs, okay, meaning to define a function according of what I want to do the optimization. So for me, the important thing is the material cost or is the construction cost. This should be one. Okay, so if I decide that the half of the importance is the material cost and the other half is the construction cost, I need to separate this in 0505. So the first thing is this. Then the important thing is the general design bounds. Okay, so this means that I have columns, I have beams, I have slabs. Okay, they have the dimension of them. So I have in the columns, I have the dimension, the one and the other dimension of the column. And this is also for the beam. And I have a lower limit and an upper limit. So I don't want to reduce the columns in order to be, I don't know, 50 centimeters or 15 centimeters, but I want to make like a lower and an upper limit. If I don't want to do this, I just keep it like this, okay? As lower up and upper limit, it considers it 30% of the existing, and I type a step means that I will reduce or increase for 5 centimeters in each step. What this means, I have a column, is 50 per 50, okay? In the first step, I will do it 45, 50. In the second step, 45, 45. But in some cases, let me tell you this because it's important, it's necessary not to reduce only. Because in some cases, if, for example, I increase these two columns, for example, okay, these are 30 per 30 and I increase them and make them 40 per 40, okay, maybe these other columns would need to reduce more. So what the optimization do is not only reduce in order to see if I pass the checks by reducing one element or all the elements. It makes a iteration, okay, because inside it contains the algorithm, okay, as you can see here, that this algorithm do this exactly thing. Reduce, increase elements in order to find the perfect solution. So, okay, and the constraints, some general constraints for, okay, the upper and the lower, okay, let's not talk so for this. Let me explain you this. I told you that I want to reduce the cost for the materials and also the cost of the productivity. So, in order to do this, I need to give the units of the costs. So, for the concrete, for example, I type, by default, I have 70 currency because each country use a different money. So I don't care if it's euro, dollars, or dinars or whatever. I care the currency for each kilo. So I have 70 something for kilo, 0.7 something for kilo, okay? And here I have the unit cost. Then I have the productivity cost. So means in order to create a beam, okay, what is the productivity cost in order to make a beam? So the concrete, the rebars, the structural steel, and also what is the labor cost for hour. After this, I have also the possibility to make some bounds in for in some elements or in a category of elements. For example, if I click pick select and I click one column, let me show you this, and I open the list. Okay, you see that I have this column, and I can see that it has this initial
dimension.
Okay, dimension, and I define a lower and an upper one with a step of 5. I can keep this, or I can lock. For example, I don't want for these columns to reduce or to increase in this direction or in the other direction. This is how I can manage how it will work. Okay, and I can do it for columns, for beams, for slabs, and also I can do it by element. So not all the columns, but only one column, and I can select it. So let me, here I am, sorry, optimization. And the next thing is to define the algorithm, as we see. And now it starts the nice thing, because here I can select the analysis. So you see that we ran we had a lot of analysis. So we will keep the Eurocode 8 general static analysis. And for the design, I will keep the Eurocode 2. So when this increasing, reducing part will happen, it will be considered according the norms. So not something that like I don't care the checks of the norms, that it considers the norms. So okay, and now I can run this optimization. So if when I start here, let me explain you now that I started, because I wanted not to talk a lot before I start to do this. As you see, what the software do now. Now the software run the analysis, okay? And now, as you see in my screen, it starts. The first step that it did is increasing all the elements in 30%. You see, they became big. The second step is to reduce them for 30%. The third step is my project, is the step of the project as it is, okay? And now after this third step starts to do the optimization. Now you see, some of them are small, some of them are big. It starts to do all the interaction, okay, in order to receive the perfect way. So I stop talking now, because now the software do everything. And please take the command now, and I will wait with you, and we will talk later.
Dr. Rajai, what you are thinking? Yeah, tell your student please about reinforcement, or if you have any problems with the distribution of the reinforcement, the dimensions.
اوكي شباب صاحيين ولا نايمين يا شباب؟
صحيح.
طيب اوكي، المشروع ان شاء الله هاي اللي حكت عنه المهندس اماليه راح نشتغل عليه اعتبارا من اليوم. تسليمه راح يكون بعد 3 أسابيع. الديتيلينج اللي اخذتوه بالفريم سيستم نفسه اكزاكتلي راح تعملوا ديتيلينج له. التقييم عليه راح يكون عليه المشروع هذا 20 علامه. كل طالب راح يكون فاليوز خاصه به من ناحيه الهايت تبع الفريم، من ناحيه الويدث تبع الفريم، ومن ناحيه السبيسنج بين الفريم، وكذلك الكروس سكشن. مين عنده اسئله قبل ما تروح المهندسه؟ شباب.
يعطيك العافية دكتور.
يا هلا، تفضل.
دكتور يا أخي المعلومات تبعت المشروع إنه وين حتنزلوا لنا إياها ومتى حتكون عندنا؟
راح انزل لكم اياها على الاي ليرنينج وكمان على التيمز.
خلص تمام دكتور. كل واحد اتصل وجاهزة ولا إنه اتصلنا قائمة وفيها أرقام من الجامعية والسوالف هاي؟
قائمة حسب كل رقم جامعي بفوت بيطلع الفاليوز تبعته.
خلص تمام دكتور، يعطيك الف عافية.
الله يعافيك. شو عندكم أسئلة بالنسبة للمهندس اللي حكت عنه عن المشروع من ناحية اوبتمايزيشن ومن ناحية اناليسيز ومن ناحية ديزاين؟
إنه ما فيش دكتور، بس إنه يعني بس نقدم فيه بالشغل حنصير نسألها، يعني حنحتاج شغلات كثير نسألها عنها.
طيب هلا نقطة التواصل راح يكون بيننا وبين المهندسة اللي هو المهندس مصطفى. اوكي
خلص
تمام دكتور تمام.
لازم الكل ينزل البرنامج مشان يبلش يشتغل ويشوف شو عنده أمور، يعني توقف عنده ويعلق معاه. كم
لأنه
واحد؟
لحد الآن بس
14
14
بس
واحد
منزلين.
منزل.
دكتور انا حاولت انزل البرنامج بس ظل يعلق معي مش قابل لا ينزل ولا.
تواصل مع المهندس مصطفى.
تمام دكتور.
ايش الفندو اللي عندك 10؟
أنا نفس الشيء، وطلبت رقم المهندس
10.
مصطفى هذاك اليوم ما حدا كتب لي إياه.
اليوم بودي لكم إن شاء الله رقمه حتى تتواصلوا معه على الواتساب.
تمام دكتور، يعطيك العافية.
يعطيك
إن
العافية.
شاء الله.
شوف هاي الاتريشن اللي بصير للخطوات تاعيتك، صار عامل كم اتريشن؟ ما شايف، خلينا نلبس نظاراتي.
19
19
هلا 20.
اوكي.
دكتور خير.
Yes, please, Amalia.
Okay, I would like to tell you until here what happens in this diagram, okay? As you can see here, I have 24 iterations already done, okay? It calculates the initial cost. That was the cost that I would have in case I took my construction like I did it, okay, with all the checks and everything we did together. But that was the initial cost. And here, in each step, I can see the improvement for this step. And here I can see a maximum improvement. So in some step, it would be here, it found an improvement of 9.7%. So the initial cost was here, the current cost for this step is here, but it found a minimum cost that is like this. So you see here that I have a nice reduction, okay, of cost by maintaining the same secure part that I have. So the checks are passed, everything is perfect, but I reduce the costs, okay? So we see that we arrived at the third iteration. I could even stop it here if we want, so we will not wait for this to finish, because I already found something that I like. Okay, what do you think? I can stop it? Because it could arrive until 100 iterations. I didn't put any limit for this. I could put a limit and say arrive until, for example, an improvement of 9%, and I don't care about more than this. So
thank you. Thank you, Amalia.
Just 1 second. I want to show you the results, because if I click stop now, okay, let me, it finished. Fantastic. So I click stop. No. I need, in order to click stop, I need to finish 1 iteration. So just a second. I don't want to lose it, so stop. And I can stop it here and see until now. Okay, until now I can see the results. So I can click here and I can see the first step. I told you it was 30% more, 30% less. My initial, okay, and then I started to have, it was a 0 improvement, but here I have also the failure degrees. So in this step I didn't have a big reduce, because you see here the initial cost. In my first step I had more cost, but the checks are good. More costs, the checks are good. More cost, not the checks good. Less cost, nice checks. So this is what you can read here, okay? Until here I had the best one, it was the 35th step. I had my best solution, okay? And if I go here on the report, I will see, okay, everything here, and I see also what this improvement was. So I see that I had an improvement on concrete, on steel bars. I don't have structural steel. Also for the columns, and for the slabs, I didn't need to have any improvement. It was good like this. So here I see also that the columns had the initial dimensions and the optimized one. And also I see the same thing for the beams, that I had the improvement of the initial and the optimized. In some cases, this is what I wanted to show you, I needed to make them bigger in one direction and smaller in another direction, for example, in order to have the better solution for all the building. And now I close the results. And if I go, this is the 35 steps. So I exit, okay, and I have my construction. I didn't lose it. This is important, okay? I made the improvement, but this is my initial one. If I want to find the improvement one, I will go to check inside my project. So it's template 1. Let me find it. Template 1. And here in the OCP file folder, I will find all the run files. So you see here, it keeps a file for each step. It's important to say that this file contains the modeling. I need to do the analysis and the design again. And this is because otherwise it would be very hard for the softwares to keep all this information, and it's not good for my local disk. So I can find this one, okay? So now if I close this, I save my project, okay? I keep it like I have it, and I open this project. Let me go in templates one, I go in OCP, run files, and I find the 035, if I could remember, and I click it. You see, here is the other project that is improved. So this is the improved one, okay? And now I need to do the loads are inside, and what I need to do is to run again the analysis and to do the member designs in order to keep this one, okay? So this is how it works, also the optimization. So I believe it's done now. So please do your homework, do what you need, and I will be always here for you. Your professor will tell me what is the needs for now on. And I thank you so much for watching these lessons. I hope they were useful, and I'm here for you. So goodbye.
Thank you very much, Amalia. Hope to have our students with their homeworks to do it.
Fantastic. Okay.
Bye bye.
Good work. Bye. Thank you. Thank you very much. Bye.
Okay, Dr. Rajai.
شباب، عندكم أسئلة؟ عندكم شيء؟ جهزوا حالكم. شباب بنات، عندكم أسئلة أي شيء؟
لا شكرا مهندس.
ليش انتم ما بتردوا على الايميلات اللي بودي لكم اياها؟ هسه بدي ادق فيكم. ايميلات ليش ما بتردوا؟
والله دكتور انا رديت.
انا عارف اللي رد علي، عارفه انا. اللي ما رد علي ليش ما ردوا علي؟ وديت لكم ايميلات، وديت لكم مسجات عشان نكون مع تواصل، عشان اي شيء بتحتاجوا نكون على تواصل، نعرف شو بدكم، شو عندكم مشكلة، شو عندكم هاي، عشان اعرف انا شو احكي كمان الدكتور رجائي.
بس
ما بتردوا
ان شاء الله اليوم نرد عليكم.
لا هذا ان شاء الله بدي اشير لكم، وانا بدي اياكم تشتغلوا عشان نعرف شو بدنا نحكي للدكتور رجائي. شباب يعني كم منزلين 16 نفر، الباقيين شو بتساووا؟
اليوم امتحانات
دشروا لي الامتحانات ومن الحكي هذا، بتنزلوا بتصيروا تشتغلوا شوي يوم بعد يوم. هاي يعني المهندسة أمالية خلصت لكم وعطتكم ما شاء الله يعني زيادة كمان، يعني عشان أي شيء بتحتاجوا دائما هي اتصال معي بتسألني شو بيساوي الشباب، شو بيساوي الطلاب، بقول لها والله ما بعرف شو بدي أجاوب لها، شو أجاوب لها أنا يعني؟ أنتوا قولوا لي بدكم تشتغلوا؟
أكيد مهندس ما نشتغل.
يعني اللي مش منزل ينزل. وصلوا لكم ايميلات مني ولا ما وصلوا؟ لانه سمعت من شباب في منكم ما وصل عندهم ايميل.
مهندس اذا غلبك الايميلات وين بعثت لنا اياها؟ على ليرنينج يعني؟ لانه ما وصلني شيء.
على ايميل كنت جامعي، ايميل الجامعه، ايميل تاع الجامعه.
حقك علينا مهندس، يعطيك العافيه. هسه خلص، هسه الكل يعني راح يلتزم بهذا الشيء، لانه فتنا بوقت المشروع.
اعتبروا حالكم انتم والدكتور بعدين.
يعني فتنا احنا، بس القصه فتنا بدوامه امتحانات، وهسه يعني بلشنا نفضى شويه. فحنبلش بالمشروع خلص الايام جاي، لانه ما ضلش وقت اصلا.
ما ضلش عندكم وقت.
فالكل حيصير يتواصل معك الايام الجايه مهندس ان شاء الله.
ما اعرف، بدكم تجننوني، مش مشكله عادي، راحتكم، ما عندي مشكله. انا قلت بدي اياكم من الاول جننوني عشان تكونوا انتم مرتاحين هسه. مش مشكله.
ان شاء الله ان شاء الله ان شاء الله مهندس.
تليفوني عندكم ولا ما عندكم؟
اليوم بنزلهم اياه يا مصطفى ان شاء الله.
دكتور بدك اياهم يعملوا اوبتمايزيشن ولا بدون اوبتمايزيشن؟
لا بدون اوبتمايزيشن، خليهم على الديزاين بس.
على الديزاين، اوكي. وطلعوا الديتيلز والهاي.
نعم، الديتيل والريبورت.
اوكي تمام.
اوكي، الله يعطيك العافيه. شكرا
يعطيك
مصطفى
دكتور، وهاي احكي معهم انت شو بدك تحكي. يلا شكرا
ماشي.
كثير كثير، وخليهم يتواصلوا معي دكتور.
ماشي على طول. شكرا لك. شكرا
الله
يعطيكم العافيه الله يعطيكم العافيه شباب، وان شاء الله اليوم بنزلكم كل التفاصيل بالنسبه للمشروع
ان شاء الله دكتور.
يلا السلام عليكم.
مع السلامه.